The ones the little kids play with.
Yeah.
They spin around.
Or the hat ones.
Yeah.
Wants 3,000 of these trailers.
Yeah, right.
We could get that down to an assembly line.
Sure.
Yeah.
Yeah. Okay, guys, so it's week 10. Basically have 4 weeks after this left in the semester. So there's this, we have 5 weeks left essentially, and we're starting, week 10 of 14. And as we all well know, the hydrogen fueling station move kind of hijacked wind and solar, but we'll do what we can to cover the material appropriately. All right, so let me just get in here. A couple of you wanted to look over the answers for the first quiz, right? Do you remember which ones in particular there?
There was
Corey?
one, it was the amount of joules in a cubic meter traveling 10 miles an hour.
Oh, super. Okay, that's a good one. That's a good one for Casey back here too, who's working on his.
I think I understand it now.
Okay, yeah. Let's just review it.
Okay.
Let's just review it. Is it one that it's probably one that I still need to grade?
Yeah, I think the other one.
Okay, good. It's visible enough, right? Okay. You weren't that far off. 24 versus 12. Could have been a units issue, but let's just check here. All right, I hope my bamboo is going to behave. Let's see. All right, so quiz 1, energy per unit volume. Okay, now one thing I want to stress here, guys, when you're solving any one of these engineering equations, and and these are engineering equations that are then applied in the technical realm. First thing you really want to do is sit down and solve the thing symbolically. You want to sit down and make sure, like, before you start plugging numbers in. So, what energy equation from Energy 101 are we going to use for this guy? What form of energy are we talking about, first of all? Yeah, so it is. It's energy equals 1/2 mv squared. What type of energy is that? It's kinetic. Yeah, rather it's not a potential energy, it's kinetic. So yeah, so E equals 1/2 mv squared. So there's your symbolic description. One thing you might see, I'm just going to say as a side note, if you ever end up in an engineering course, you might see it written this way: T equals 1/2 mv squared. Bizarrely, if we were in if we were looking at a potential energy, so this is obviously kinetic. I'll just put that up here. You would see, don't ask me why, but V equals mgh for potential energy. So typically T is the symbol for kinetic energy, if you ever see that. V is sometimes the symbol for potential energy. But for our purposes, we're just going to use E for energy. If it ever came up, you might put a little K here for kinetic, so you can remember that. But anyway, all right. So in the question, well, so we've got what do we got here? We got one equation. Another thing you should keep in mind is like how many equations, how many unknowns you're dealing with. We got one equation, obviously. How many unknowns here with the E equals 1/2 mv squared?
Energy, right?
Yeah, and this really is our unknown. Velocity is given in the statement, right? 10 miles per hour. There's the velocity. So we know that for sure. Do we know the mass?
We know the density of air.
Yes and no. I mean, so effectively, we do know the mass. We've got one equation, one unknown. We can solve it. So right off the bat, you should feel good about that. So what is the formula for mass if you know the density and the volume? I always think of it like this. I've got density equals mass per unit volume. I just write it out that way out of habit because you know that density is written that way. Another thing I should mention, this symbol is the symbol rho. It's not a P, and when you're drawing it, get in the habit of drawing it the way I just did. Start at the bottom and just give it one of those. It's a single stroke. There's no little serif on the top. It's a rho, not a P, and so just get in the habit of drawing it that way. So rho equals mass over volume. That's a big V. If in your notes you want to distinguish, sometimes you can put a couple little serifs on to make sure you're talking about volume instead of velocity. This dang thing, just there to confuse you, but just want you to know, sometimes that V is used for potential energy too. All right. Now, so we've got, density is mass over volume, mass equals density times volume. So again, based on what I said 5 minutes ago, you want to solve this thing symbolically first before you start sticking the numbers in. So equals 1/2 rho big V little v squared. Now, we still have one equation and one unknown, one equation, one unknown, because we know the density, I gave you the volume, and we know the velocity. So from here, really the only error you can make is an arithmetic error. We have not made any algebraic errors so far, or you might make a units error. Those are really the only two errors you can make from here on out in solving this problem. So we got our 1/2, we've got our density, and 1.20. So I kind of like to put these things in parens. You can do whatever you want. That way you don't have like little dots and X's and things flying around. Just throw the parens on there. 1.2041. And since we're going to work in SI units, but I gave you the problem in English units, thanks. We'll keep the units here. So this is kilograms per cubic meter, and 1 cubic meter, so we'll write that in there, 1 meter cubed. I'm just going to erase this guy. And then V squared. So let's do our little units conversion over here on the side. So 10 mph to m per second. And Google's already thinking for me. It's told me the answer before I even finished typing. 4.4704. 4.4, what did I say there?
704.
Thanks. 704. And there's a couple different ways to write this, but I'm going to go ahead and just put the meters per second in here and then square it. Now, important thing to keep in mind, I think this is something that, I think can screw you up a bunch of times, is you have to square the number and you have to square the units. Okay, so let's just go ahead and run this through the calculator, and it doesn't matter where we start. Everything is multiplication. I'm going to save that division by 2 until the last step. That's just kind of easier for me. So I'm going to do 4.4704 times 4.4704 times 1 times 1.2041 divided by 2 equals. So did you maybe just forget the divided by 2?
I just did
That's all it was, okay, okay. So there we go. So there's our 12. So we got the arithmetic correct. Now let's just go back and check the units, okay? So kilograms survive, meters cubed die, and then we got meters squared per second squared. So that's great. I mean, that is the definition of a joule. 1 joule is it's 1 Newton meter. And if you forget what that is, 1 Newton equals 1 kilogram meter per second squared. And if you multiply a Newton times a meter, you get a joule. Kind of cool. Okay, so there it is. And that's, I kind of beleaguered that, but that shows you kind of, how to solve a problem in general. You don't want to start throwing the values in them until you're locked in solid. Right here, you've got 1 equation, 1 unknown, and it's just plug and chug from there. Okay. Anything else on that first quiz, or so it looks like you just forgot the 1/2.
Yeah. It was,
Common error,
I mean,
not a
it kind of
problem.
made sense, it just didn't.
All right.
I
Okay.
didn't know that.
Yeah. So I guess while we're on the topic of wind, there's a couple other things that I want to cover, and one is the derivation of Bets Law. It's fairly involved. It's not easy, but let's dig into it nonetheless. I'm just going to pause this, and then I want to cover Bets Law. Then I also want to cover Bernoulli's equation too. It's important, especially for wind, even for solar thermal. Bernoulli's equation is the foundation for a lot of this. So we'll do Bets Law for a half hour. We'll do Bernoulli's equation for a half hour. If there's anything else in particular I want to cover, I'm happy to. But those are the 2 things I really want to hit today. Is that good for everybody? Okay.